talk about cost savings and cost cuttings when you talk about cloud, right? So why am I getting such a big bill? You have to tell them, okay, you just forgot to turn off the VM. So yes, with this, I'm going to call our next speaker, who's going to talk about how he did cost cutting by 90% while increasing the efficiency of a solution by 10x in his current company. So with a big round of applause, let's call Anubhav Singh here, who's the co-founder at, mic cut off before I could introduce.
Am I audible? Yeah. That was the question we asked in 2020. Thank you, Vijita. Yeah, okay, they gave me the slides. Cloud cost optimization from $1,700 to $150 at 10x the performance. Right, so a bit about me. Hi, I'm Anubhav Singh, and yeah, I'm the co-founder for DynoPy and a couple of other things. You can just scan that QR code in case you're interested to know more. Let's start with why the topic, right? Why am I going to talk about cloud cost optimization? किसके लंबे बिल आए हैं cloud में? You're okay with Hindi, right? Everyone is okay with Hindi? Yes? Anyone who is not okay with Hindi? Perfect. Yeah. किसके लंबे बिल आए हैं? किसी ने दिया 1 लाख? वो पीछे भाई कितना आ गया था? Yeah, there's someone else. Like some people paying bills worth above 1 lakh. Interesting. So cloud costs occupy over 50% cost of revenue of the top companies, right? This is provided by A16Z, and this is the data from just last year, right? And yeah, this is pretty much summing it up, right? Yeah. So what are we going to talk about today? We are going to talk about this, right? We are not just going to talk about saving money, right? Kanjoos nahi hona hai. We are also going to talk about modern problems require modern solutions, right? I tried to do that pose. And before we start, I'll call upon a volunteer, and yeah, from the front row, yeah, sir, please. बाकी आ जाइए. Thank you. I'm joined by Faz. And I'll be taking your help for the rest of this session. And right now what I'm going to do is, I'm going to imagine that, yeah, I had a lot of money, and Faz is representing Dharmesh Cloud Services. Kudos to Dharmesh sir over there who owns the company. And yeah, please. And what happened is I got my monthly bill, right? And I am going to pay him $500. कोई बोल रहा है डॉलर नहीं है ये? Anyway, yeah, I paid him $500. He's happy. Look at his face, right? Yeah, please stand on the side. I'll need your help more a bit, right? Okay. So coming to the agenda. Yeah. पैसे दे दिए यार, अब तो वो खुश है. So the impact of cloud costs on the global industry, right? So, and then we'll be talking about some solution bottlenecks which you should be thinking about, and then we will talk about how you might be overspending and how you would identify that, and then we will think about a general strategy towards solutions that cost less and perform more, and then finally we will be talking about budget monitoring for a short while. And while I'm talking about all those things, I'll also be talking about a case study of my own company where we reduced the cloud cost from $1,700 to $150, although I'll start at a higher number, right? So this was the case study about, so there's a video processing solution which was required by one of our clients, and they were going to send us some links which had videos on them, and these videos were actually about users filling a form. And that form could be multi-step. These forms were actually in many different formats, right? So these could be multi-step, these could be coming with pre-filled values. These forms could also be in different designs, right? You see forms in all shapes on the internet, right? So this was the problem, and we had to take out the data from that form, right? We were supposed to extract all the data that was there in those forms, and we were supposed to send it back to the client, right? The client wanted to send us videos, and we were supposed to send him back the data from that form. Right? This was the problem statement, and we'll talk about the solution that we came up with later. Let us talk about the impact of cloud costs on the global industry. And by 2020, starting from 2010, where it was almost nil, it went up to more than $100 billion. Just 10 years. Right? This is how much cloud has been impacting the industry on a global scale. And if you look at the cost of revenue for some of the largest players, right, I'm pretty sure you know all of them. And if you look at them, then they are spending up to almost 50% of their entire expenditure on revenue. Like for the cost per revenue unit, they're spending 50% of it on cloud. Yeah, I hope it works. And yeah, instead of asking you to read the entire thing, I'll just ask you to focus on this, right? So there's estimated 100 billion of market value that is being lost by just cloud margins. And then the total impact potentially, including all the startups and everything, this is just for the top 50. So if you think about all the people who are using cloud, it is probably around 500 billion. That's almost $500 billion. Right? I could probably fill this entire screen just writing the zeros. And if you look at the impact of cloud in India, so there are a few figures that I have here. Please feel free to go through them. India's public cloud market stood at 5.6 billion, and 53% of the enterprises have increased their cloud adoption. 84% of large organizations have adopted SaaS, potential to grow around 8% of India's GDP, right, by 2026, and creating 14 million jobs by 2026. That is the amount of impact cloud is going to have, projected to have in India. But at the same time, now this is the first solution that we came up with, right? So what we were going to do, we were going to fetch the video recordings from the client, and we were going to run computer vision algos on them. And we all know how accurate they are going to be, because computer vision on a form which is shifting and which is coming in thousands of designs, it's going to just give us very horrible results. And it took an average of 10 minutes to process one video. 10 minutes to process one video, because these videos could range from something like 3 minutes to 1 hour. Sometimes you take a lot of time to fill a form, right? So these were going to take a lot of time, and 10 minutes for processing a single video. The cost was around $3,000 per month. That is what we billed the client for the first month, almost $3,000. And we could process around 60 videos in 1 hour, right? Because we were running multiple VMs doing the same stuff. Right? So 10 VMs doing the same stuff, we could process around 60 videos in an hour. And this was the first brute force solution that we came up with. I'll talk about the rest later. And for reference purpose, this is what I'm going to show you in the rest of the slides. Solution bottlenecks. Right? So this is the case scenario. You are the wolf of Web Street. Right? And your software is very famous. You're reaching a lot of users. Daily activities skyrocketing, and that is exactly when the problem for costs start. Right? Not exactly that's where it starts. It starts way before, but that is when it starts, showing up in your dreams at night. That how much am I spending on cloud? Right? So let's do some math. Right? Solution bottlenecks. So there's two ways of writing split of a string, and in JavaScript, right? How many of you here do JavaScript? JavaScript. Sabne kara hai? Sabne ye wala kara hai? Right? Everyone has done it. Nice. And what I'm going to ask you is, which one is better? Which one would you choose? How many of you choose the first one? Couple of hands here. Okay, I think around 15, 20 hands. Okay, the second one? Popular. Yeah, around 50, 70 people. Now look, if you look at the comparison of these running a million times, the string.split actually works faster, and the other one runs 74% slower, 74%. Right? So if you have the spread operator used all through your code might be performing slightly less when it is running for 1 billion users. Right? So if you had 1 billion users on your website in a single second, this would actually mean that you are left with 260 million users. How would you like that? So you also need to identify the solution correctly for any problem, right? So let us ask these questions to ourselves. Is your solution approach feasible for the problem at hand? This is very important, right? How you are going to approach the solution to that problem which you have been given, that is very important. You could think that problem is going to be solved by something, and then it turns up that it's actually going to be solved by an entirely different approach, right? And then are you going to use the technology that you like or technology that's needed? Every project will have an ideal solution, not exactly the perfect solution, right? But it will have a solution which is kind of the most feasible, and it will demand a tech stack, right? A lot of us make mistake that we try to solve every problem using the technologies that we are comfortable in, right? How many of you do that? You know, I know this language, so I'll solve every problem with this language, right? So this is something which will actually has the potential of churning out solutions which are not great. So you should always let your solution's requirements dictate which technologies you are going to use. And then, is it possible that a non-conventional approach can solve your problem, right? And if you remember our case study, I talked about how we were going to use computer vision to solve that issue, right? There was this recording of the screen of a user filling a form, and we were going to extract data using computer vision from that form. And then we were hit by a lightning bolt, because we realized that this does not have to be solved by video recordings. What we could rather do is we could record the events happening on that page, all the clicks, all the mouse events, all the keyboard inputs. We could record that very easily using JavaScript, right? We could record all of it, and we could use that to extract data. Do you agree? Do you understand how it's happening? Right? पहले लोग वो स्क्रीन में सब कुछ डाल देते, हमने स्क्रीन रिकॉर्ड कर ली, we were trying to take out data. This was giving us a lot of problems, right? But then we changed our approach entirely. हमने क्या करा? वो जितनी बार क्लिक करे वो हमने लॉक करा. की लॉगर सुना है ना? Right? We know how dangerous that is. That is what we implemented, right? So we implemented this in that particular web page. In fact, array of web pages. Like there were a bunch of web pages, and we implemented it there. And this was actually just a screenshot of the screen and then the JSON events which were happening. So we did that. And then we did not have to look at video anymore, right? So it was not a problem of video processing anymore. It was just a problem of reading the events data from JavaScript. That was how small we made it. And then we deployed this solution, right? And we put the entire solution flow on the same VM. Now this was again problematic because there were different steps which were taking different amount of time, right? So parsing the JavaScript would take a different amount of time, but loading the page from client server, that was going to take a bit of time more than that, because that was a network call. You were gathering a lot of data from that side. So you had to fetch the entire page. You had to run regex on the data which was being collected, and every link took around 2 seconds. Now we started from 10 minutes per video, and we came down to 2 seconds, right? And then there was negligible error in the data because key logging kar rahe yaar, kahan galat hona hai, right? So the cost came down to almost $1,700 per month, and this is where I start talking about the cost, right? Because isse pehle jo humne kara tha, that was not a solution, that was just a pain, right? So yahan pe I start talking about the solution. This was $1,700 per month, and we could process around 2,000 videos per hour. Big improvement, right? So what we did, we brought down the cost by 43%, and we increased the speed of the system by 33x, right? And that is where we reduced 43% of our costs. So Faz, please, you should be returning me 43%, that is 215. Yeah, return me 215, please.
So I don't have the exact amount.
You don't have the exact amount? I'll give you change.
Okay.
There you go.
Thank you.
215 reclaimed. Yeah, smiling pen. So how do you identify you might be overspending? How do you identify that, right? So there's a very beautiful billing dashboard which is provided by GCP, if you're using GCP, right? And it does a lot of things, right? It shows you how much you have been spending on each service by each project. And remember, if you use a lot of tags on all your resources, right? If you tag them in the right fashion, you can actually track down by each tag. Say, for example, you created a staging deployment, you created a production deployment, you created maybe multiple deployments for multiple customers, right? So put a tag on each of them, put the right format of tag for each of them, and you will be able to track, how much you are spending by each customer, how much you are spending on your development setup, right? So do that. Use tags to have a very nice billing report prepared automatically by Google for you. Otherwise, you could take that, you could also look at the recommendations which GCP has shown you for your deployment, right? Whenever you go into the GCP dashboard, right, the first screen which appears, on the top in the right side, there's a recommendation section. You can go there and you can see all the recommendations that they have for you based on how you have been using your resources. And if they identify that maybe your volumes are sitting idle, maybe your VMs are sitting idle, right? There's a lot of idle time for your VMs. So they will give you recommendations about how you can change your configuration to reduce your costs. And that is actually very helpful, right? And then finally, if you want more fine-grained control, if you want to build custom dashboards for your billing, you could actually pull all your data, all your billing data to BigQuery, and you can create custom dashboards in, say, Data Studio. Or you could also create that in Google Sheets for those of you who are more comfortable with that, right? So pretty much anyone can take all the billing data and create a very nice dashboard out of which is specific to you, specific to how you define what is your unit of measuring costs, right? And based on that, you can create these dashboards, find out anomalies, find out if there were unexpected expenditures, right? So this is how you do it. And then finally, coming to a general strategy to a solution that costs less and performs more, right? So the first thing that you want to do is break down your solution, right? Don't put your entire solution in a single VM. That is going to be a disaster. Break down your solution into smaller components, create a deployment for each of those components, and let them talk to each other in an asynchronous fashion, right? That makes sure that if one part of your application is shut or goes down or anything happens, it's just one part of your system which is getting affected, and the rest of your pipeline keeps working, right? So break it down. And then if you break it down, there's a possibility that you could be reducing your costs, right? Think about this. If you have a very simple example, if you have a website which takes user input from a form and you store it in a database, if you deploy a database, the backend and the front end, all in a single VM, you will have to think about what happens when there's millions or billions of people coming on that particular page. Will your VM scale up to that? It will have to. Otherwise, how will you provide your customers with the critical business needs, right? So if you put all of this in the same VM, that's going to be painful because your backend is probably doing just a small amount of work, like a very tiny amount of work. Your front end is just serving pages and just taking input for one form, right? So that's not a great idea. You could put it on different types of resources. Put your front end on a static hosting site. They're very cheap, very cheap. In fact, free in most cases. GitHub pages, right? Firebase. Put it there. It's like generous amount of free tier on those. And then your backend, you could put it on, if there's a single script which is just taking some data, put it on something like Cloud Functions or maybe any other offering which provides similar runtimes. I guess Heroku is very popular among students, right? So you could do that, and that will actually save you a lot of cost. Okay, I kind of explained it. Okay, so some more math, right? Some more math around breaking down your problem and putting your solution on different resources. And yeah, this is kind of uncharted, so we'll do that. And yeah, this is Chatur VM, right? We have a Chatur VM which responds to 100 web server queries per second, and it can process 10 videos per hour, and it has a DB read write at 100 queries per second, and cost per day is $20, right? So this is Chatur. And then we also have Rancho, right? Hona banta hai, right? And then this can respond to just 10 web server queries per second, but it can process 100 videos per hour, right? And iska bhi DB read write same hai, iska cost $10 hai per day. And the problem that you have at hand is you need to create a deployment which can respond to 50 concurrent web server requests, and it can process 100 videos per day. Sorry, 1,000 videos per day. Right? This is the problem that you have at hand. Then how do you solve it? Right? Do you do 5 Chatur VMs because you need to process 1,000 videos? To do that, you will need 5 of them. Or will you do 5 of Rancho VMs? And if you look at the cost, right? So Chatur's VMs are costing you $100 per day, and Rancho is just costing you 50. Which one will you choose? Those for Chatur. यार कोई नहीं है उसके साथ. Like not a very bad guy, to be honest. मेहनत करी थी उसने. Anyway, Rancho के साथ कौन? Yeah, some of you. सर आप किसी के साथ नहीं हो, आपको क्या दिक्कत है? Yeah, anyway. So $50, much better. पैसे बच रहे हैं, काम हो रहा है, right? But what if I told you that you could do both, one of both? Does it solve your problem? Down there, yes. What is the cost? 30. Right? Even lesser than what Rancho would have done for you. So yes, Chatur is a nice guy. Yeah, that's the lesson I had today. Anyway, right? So this is the table in which I show you how it compares when you scale it up to 1 billion users. And this changes things a bit. Because just now I said Chatur and Rancho working together is better. But if you look at this chart, then you can see that the best one is actually given by 5x Chatur VM. Right? So the solution, yes. Yeah, I said something and then I contradicted myself. But the point which I want to set out is something which works best for one day might not be the best scene for working it for a month or maybe an year. Right? So you need to keep this in mind when you're designing your solution. How long are you going to run it? Are you going to run your solution for 1 year? Are you going to run your solution for 10 minutes? This is very important when you're deciding what kind of setup you're going to do. And then use auto-scaling, right? And when should you use auto-scaling? From day one. Because your development team will not always be working on the same project. If you have multiple projects, they will not always be working on the same project with the same amount of hours put in for the entire duration of their stay at your company, right? Sometimes some project will be more prior, sometimes some projects will require more resources. And you just want to use auto-scaling for all of this so that whenever your traffic for that particular clients increase, or maybe whenever your developers are using it more, right? So it scales up according to the needs of your company. And that will actually save you a lot of money from day one. And if you think about that, right, the example which I've given here is of a VM that caters to the office work of bank employees. So when do you think it will spike? During the bank working hours, that's it. For the rest of the time, it will be shut down. That particular VM should be shut down, right? So if you use auto-scaling, if there's a huge rush, maybe Dhanteras aa raha hai, if there's a huge rush at that time, then it will scale up. But on the other days, it will keep on, just running on the minimal resources. And on bank holidays, it will probably entirely shut all the pods and be at 0. And then finally, you need to look at spot VMs, committed users discount and all that. That will actually save you a lot of money. And yeah, you could spin up spot VMs. Spot VMs come with a small issue that they can be shut down anytime. GCP will just send you a signal that I'm going to shut down this VM. And you need to make sure that whatever solution you are running, it is tolerant to being shut down. It can spin up later and continue that particular batch job or whatever you're doing so that it gets completed without any issues. And then coming back to our case study, right? Thinking about what we have learned just now, auto-scaling, breaking down the solution. So we are going to implement that in our case study now. And this is what we did. Single machine deployment was not great. So we broke it down into 4 parts. The first part was receive a link and just store it. Simple as that. The client sends us a link, we store it. Done. That particular application says, my work is done. I have stored it, my work is done. The second one, it fetches data from that page, right? It fetches the events data, stores it. Done. The third one, parses the data which is being sent to it, which is already saved in the storage. It just parses that data and says we are done. And finally, there's another one which is sending that data back to the client and calling it a day. Right? We broke it down into 4 parts. And so these components, all of them were deployed as auto-scaling apps. So if for a particular time, the client starts sending us huge amount of data suddenly, we will scale it up. Because the client used to send us data in primarily 3-4 hours of the day, and the rest of the day there were just some small amount of data which were coming in. So for those 3-4 hours, it had to scale up. The one which was receiving the links, it had to scale up immediately. The one which was processing, it will scale up after that. Because the one which was receiving the links and storing it, that was informing the processing application that now you need to scale up, ramp up your game, get the videos processed. Right? And then when that did that, the third one actually scaled up. And finally, the fourth one scaled up, right? So you get the idea. So initially, the step 1 was scaling up, and the second one, the third one, and the fourth one. And then finally, what will happen? The first one will go down, the second one will go down, and so on. This is what we were doing then. And each component was non-blocking because none of it was waiting for the other to complete its task. The first one could be working on 1000th link, the second one could be working on the 700th link, and the fourth one could probably be working on the 100th link. Right? None of them have had to wait for each other to complete their tasks. Each link took around 4 seconds for processing. Now this is where we kind of went up from 2 seconds to 4 seconds. But then at the same time, the cost was around $150. And it could process 50,000 videos per hour. Although I'll give you this number 50,000 because that is the maximum the client sent us in 1 hour, one fine day. If they would have sent us more, I'm pretty sure this architecture could have handled way more than this. And this is what we did. We reduced the cost by 91%. And our efficiency went up by 25x. Yeah, please. 91%. Yeah, such a nice cloud provider. Deals in cash. Yeah.
Yeah, 10 people.
Can you show them how much do you have remaining with you? Yeah, okay. 10 rupees short. He was giving me less money. Can you show them how much do you have remaining with you?
25.
Okay, chiller. Thank you. Thanks a lot. Yeah. He's such a nice sport. He's still smiling.
Smiling in face.
Yeah, so this is how much we reclaimed back, right? We started with paying $500, and then we came down to paying just 25. Do you like that? How many of you like that? Yeah, some of you, all of you? Perfect. Yeah, आपको ये भी नहीं पसंद है? Yeah, so finally, budget monitoring can save your day, right? Monitor your budget, it's very important. Maybe as a developer you don't feel it, but I'm a co-founder and I see the bills every day. मेरे को लगता है थोड़ा इधर, right? So monitor your budget, not just because of you, because you might be allocated team budgets, you might have a strict budget to work in, you might have a limit to the resources that are available to you. So make sure that you're monitoring and making the best out of all of them. And this is what budget monitoring does for you, right? It gives you a very clear visibility into how your application is performing, right? If your application's bills suddenly skyrocket, you could think about something is wrong. And if it actually goes to 0, you could think about the system has shut down, right? So you could always use the billing metrics to understand if your solution has been performing correctly. And then you can charge it back to the teams. Which team has spent how much on which project. You can actually look at that and you can decide how you're going to move forward with that project, how much budget you're going to allocate. And then you could also prevent budget overruns. This you can do by the one which I have written later. You could set up alerts. And in case you have set up alerts, you could also set up custom actions. So say for example, one fine day someone decided to DDoS your system, and all of a sudden your logs for errors went skyrocketed. At that time, you could put a limit there that if the number of logs is exceeding this amount of budget in a particular day, just cut off that service for a while. And that is actually going to help you because then you have kind of cut down the costs. But at the same time, you need to figure out other ways in which you could keep the applications running as well. You could start showing, we are experiencing huge load, please expect delay. You could set up, resource constraints in which people cannot, API constraints in which people cannot access more than, say, 50 requests per second. And finally, you could bring forth billing of unused resources, because if you're looking at your billing metrics every day, the budget, then you will be able to figure out that there are some resources which are lying unused, and you could just choose to terminate them or find another solution for them. Right? And this is how you can do it with the budget API. There's a budget API provided by Google, and you could use it to send yourself an email, or you could also use it to inform your customer about them overspending, and probably use it with any integration like Slack, any email service, or it could be anything. Send an SMS that you have overrun your budget. And finally, I'll say, like, a lot of people tell me when I talk to them about scaling up their solution and stuff, they tell me that I'll put it on the cloud. That is going to be my solution. But I'll be honest, right? Cloud is not a plan. Cloud is where you execute it, right? So putting it on the cloud is not the solution. You will put it on the cloud, and then you will implement a solution there, right? So remember this. And I do have some time, so I'll take maybe a question. Anyone? Questions? Yeah, if there are no questions,